all. Today we'll be discussing the LeetCode problem of the day, minimum difference between highest and lowest of k scores. So you're given a zero index array where nums of array represent the score of the ith student, and you're also given an integer k. So in this you have to pick the scores of any k students from the array such that the difference between the highest and the lowest of the k scores is minimized. So you have to return the minimum possible difference that you can pick. So for example, here the array size is only 1 and k equal to 1. So you can only pick the score of this student. So the minimum is 90 and the max is also 90. So your output will be 90 minus 90, which is 0. And this is the minimum difference possible. Now for second input, you have the array size as 4 and k equal to 2. So in this explanation, there are 6 ways to pick two students, two scores. So in the first way, you pick 9 and 4. So the maximum score is 9, the minimum score is 4. So the difference is 5. Similarly, you can get all the differences possible. So among this, if you pick 9 and 7, you will get the minimum difference, which is 2. So the answer is 2 for this case. Now coming to the constraints, the array size and also k will be from 1 to 1000, and the values in the array can be from 0 to 10 power 5. Now let's go with the approach. So suppose you have these scores arrays, and let's say we sorted the scores and k equal to 3. Now let us pick any random 3 scores and let's see what's the difference. So suppose I pick 5, I pick 10, and maybe I pick 17. So my 3 scores are 5, 10, and 17. And our goal is to minimize the difference between the highest and the lowest score. So in this example, the highest is 17, lowest is 5. So your difference will be 17 minus 5, which is 12. So here our answer is actually equal to the highest minus the lowest. So instead of picking 17, so if you pick 15, then the highest changes from 17 to 15. So when we do it, our new difference will become 15 minus 5, which is 10. So same argument can be made with the lowest as well. So if we try to increase the lowest from 5 to 9, then the difference reduces even more. So 15 minus 9 is 6. So basically, if you want to reduce the difference, then the minimum value and the maximum value should be as closest as possible. So in this example also, we can further optimize it. So instead of taking 15 as the maximum, we can maybe pick 11. So when you pick 11, you'll get the new difference as 11 minus 9, which is 2. So in this example, 2 is actually the smallest answer. So what we can see is it is always optimal when you pick all the k elements which are always consecutive. So the approach is pretty simple. Since k equal to 3 here, first you'll check these 3 values. And for this case, the answer will be 9 minus 1, which is 8. Then next you will pick these 3 numbers, 5, 9, and 10. So difference between the highest and smallest is 10 minus 5, which is 5. Next, you will pick these 3. Let me erase it. Next, you will pick 9, 10, and 11. So in this 3 consecutive scores, the maximum minus minimum is 2. Next, you will keep moving forward. You will pick 10, 11, and 15. And the maximum minus minimum here will be 5 minus 10, which is 5. And finally, you'll pick 11, 15, and 17. So in this case, the difference will be 6. So among all these consecutive differences, since 2 is a minimum, this is what you'll return. So one thing we can say is always our answer will lie at the consecutive positions. Now let's quickly code the approach. So first step is to sort the array, and then you'll start iterating on the k elements. So equal to 0 less than num sort length minus k. Also, we need to take a variable which will show the answer, and initially we will set it to integer dot max value. So first, let me write these numbers here. 15, 17. So initially your I will be here, and the window is from I to I plus k minus 1. So here k equal to 3. So it will be I to I plus 3 minus 1, which is I plus 2. So I and I plus 2 will give you the first three numbers. And when I keeps moving forward, the window also keeps moving forward. So you just need to find the minimum of answer of I plus k minus 1, and sorry, it's nums of I plus k minus 1. So nums of I plus k minus 1 is the greatest in the current window of size k, and nums of I is the smallest in the current window. So this difference we'll try to minimize across all the windows. So answer equal to math.min of this difference. And if we see, we need to run this loop until I reaches here. So when I reaches this point, this will be the last window formed. So for that, we need to run the loop till array length minus k. So I is less than equal to array length minus k. And at the end, you'll just return your answer. Here I also need to pass the answer. Okay, let me submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. Coming to the time complexity, since we are sorting the array, this will be n log n, and after that we are just iterating on the array, so this will be order of n. So total time complexity will be order of n log n. And coming to the space complexity, we are not creating any other additional arrays, so we are just creating the answer array and the iterator I. So space complexity will be constant, so it will be order of 1. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. Let's catch up in the next video.